Hello, Accelerated Math 7-8 students. This is Module 14, Lesson 23. And Module 14, Lesson 23 is called The Defining Equation of a Line. And our goal for today is today we will practice graphing lines to see if they represent the same line. The question that I want you to think about is, can two different equations represent the same line, and why? All right, so let's check it out and see. Things to remember, it's all in the graph. So the first thing that it asks you to do is it asks you to graph these two lines. All right, so for me, I'm going to change them into slope-intercept form. So we'll do one on one side and one on the other. So we have negative 16x plus 12y equals 33. So I'm going to add 16x to both sides. And I'm going to remember slope-intercept form requires the slope and the x to be right next to the equal sign. So now I have 12y equals 16x plus 33. Now I'm going to divide everything by 12, and I get y equals 16/12 x plus 33/12. And I don't like that. I want to simplify it to make it easier. So I'm going to write y equals 4/3 x, because I can divide both of these by 4 and get 4/3, plus I can divide both of these by 3 and I get 11/4. So that's much more manageable. So the m in this one is 4/3, and the b in this one is 2 3/4. Okay? So there's that side. Now I'm going to do the other one, which is negative 4x plus 3y equals 8. So I'm going to get the x on the other side, remembering that I want it close to the equal sign. So I have 3y equals 4x plus 8, because the 8 is positive. Divide each term by 3. So I have y equals 4/3 x plus 8/3. So the m in this one is 4/3. The b in this one is 2 2/3. Okay? All right, so that should help me. Now I can graph them. So it says graph both lines. So I'm going to go back to my light purple. So my b is at 2 3/4. So I have 1, 2 3/4 is about here. So 2 3/4, and then I'm supposed to go up 4 and over 3. So up 1, 2, 3, 4, 1, 2, 3. So it would be about there. Okay, up 1, 2, 3, 4, 1, 2, 3 would be about there. Okay. So there's that line, and let me go ahead and draw it in so that we have that done. Okay, so there's that line. Okay, and now I'm going to trade colors so we can draw the other line, and it says go up 2 2/3. So it's just a little bit under there. And up 4 and over 3, so just a little bit under there. Up 4 and a little bit under. So it's going to be hard to see, but the line itself is not, if we graph it correctly, I don't believe that it's the exact same line. So as you can see, it's not exactly the same, but it's very, very close. Okay, so now it says compare them. So this is how we compare them, graphing them. Now I want to show you a different way to compare them, because these are so close. This is 2/3, this is 3/4. That's the only difference. The slopes are the same. There's another way to compare them more accurately, and so we're going to look at that too. So it says what you're supposed to do is you're supposed to take the A value from this standard form, the B value from this standard form, and the C value from this standard form and write it on here. So the A value for this line is negative 16. The B value is 12, and the C value is 33. Then let's do for the other line. The A value is negative 4, the B value is 3, and the C value is 8. So then the last step that you have to take is you're going to take A divided by A, B divided by B, and C divided by C. If they all have the same answer, then they're the same line. Okay, well that's not so difficult. So let's try it. What if we have A divided by A, so we have negative 16 divided by negative 4. A negative times or divided by a negative is a positive 4. So that one equals 4. 12 divided by 3 equals 4. 33 divided by 8 does not equal 4. So are they the same line? The answer is no. And we proved that by the graph being off just a tiny itty bitty bit. Oh, this one's the same, this one's the same, this one is not the same. So the answer to the question is, can two different equations represent the same line? The answer is yes, they can, if the A divided by A, B divided by B, C divided by C all have the same answers. And since this guy doesn't, then they are not the same line. If this happened to be a 32 instead of a 33, then it would have been the exact same line. Okay? So that's kind of easier. It's easier. Graphing it helps us see it visually, but knowing that all we have to do is divide the coefficients, the common coefficients by each other, and if we come up with the same answer, then it is the same line. If we don't, then they are not. Okay? So today we will practice graphing lines to see if they represent the same line, which we did. Can two different equations represent the same line? Yes, if all the coefficients divided by each other, same coefficients divided by each other, end with the same answer. Okay? And that's how you answer it. All right, kiddos, that's all I have for you. I'll talk to you soon. Bye.